Okay, so now we're looking at page 204, example 2. And we're told a machine produces rectangular sheets of metal where the length is 3 times the width. Then equal size squares are 5 by 5 are cut out of each of the corners so that the sides can be folded up to shape an open box. There would be no top to the box. Okay, so again, to get this started, we're going to draw our picture here. So again, we start with a sheet, and the only thing we know about this sheet is that its length is 3 times the width. So again, I'll call this x, and then this would have to be 3x. Okay. But then to form the box, we cut out a corner from each side, or each corner. And remember, these are 5 by 5 squares. Okay. So what we have here, I would have it dotted here in red. This would be the bottom of the box. And then these, the corners are gone. Cut those out. And then we have these 4 flaps that get folded up. So notice when we fold up the flaps, it would be 5 inches high, the box. Okay, but this part here is the bottom of the box. So we're going to need the dimensions of this. Okay, so this side right here, remember the whole side was x. We just cut out 5 inches from each side. So that's x minus 10. And then similarly here, remember the whole side was 3x. But again, we cut out 5 from each side, so that's 3x minus 10. Okay. And so our first part A, we're asked to find the volume of the box, the function. So v of x, okay, well, it's length times width times height. So we have one side to be x minus 10, the other side to be 3x minus 10. And then don't forget the height, right? When you fold it up, the height is 5 inches. Okay. We need the domain, the restrictions. By the way, I'm not going to multiply this out, but you should see you have an x times a 3x, so that's times the 5. So in fact, you'd have a 15x squared for your leading coefficient. This is a quadratic, so when we get it graphed, it should be a parabola. All right, let's get our domain, so the restrictions on x. Okay, now remember, x was how long this side was. Okay, so initially you might think, well, it has to be positive. Okay, but remember, you're going to cut out 5 inches from each side, so it has to be at least 10 inches, a little bit bigger than 10. So that you have enough room to cut 5 from each side. Okay. How big could it get? Well, I don't know that we necessarily have a restriction on that. The bigger the piece of paper, or the bigger the sheet of metal, the bigger the whole box becomes. So I think this would probably be the only restriction. Maybe I write like this: x just has to be greater than 10. Okay. Part C. It says if specifications call for the volume to be 1,435 cubic inches, what should the dimensions of the original piece of metal be? Remember, the original piece of metal was x by 3x. Okay, so notice we're working backwards here. We already know the volume should be 1435. We know the output of the function. We have to work backwards to figure out the input x. So again, we're going to set our function x minus 10, 3x minus 10 times 5. We want that to output 1,435. Okay, but again, it's a quadratic equation. We can solve this. Okay, so I'm going to multiply. Now I will multiply it out. So I'll put my 5 in front here. So we FOIL this. So we have 3x squared. We have a minus 10x and a minus 30, so minus 40x. Plus 100. Equals 1435. Distribute. So I have 15x squared minus 200x plus 500 equals 1435. All right, we have to get it equal to 0, remember, so I'll subtract that 1435 over. And finally, it's in a good form for us to try to solve. So I think that's minus 935. Fortunately, if you check, this one does factor, so clearly I can take out a 5, so I'll take out that greatest common factor first. Notice, though, you needed to bring in, had to distribute the 5 first, so you can get their constants together. And now we factor the 5 out. So it'd be 3x squared minus 40x, and 5 goes into 935, 187. Again, you can mess around with this a little bit, but it does, in fact, factor. So it becomes 3x plus 11 and x minus 17. Okay, so our solutions to this would be x equal to negative 11 thirds, or 17. Right? That was the only one that makes sense. Remember, we needed x to be greater than 10. So let's just do a quick check here. If x is 17, do we in fact get the right volume? Okay, well remember then the box, you're going to cut out 5 inches from each quarter. So 17, take away the 10, would be 7. The other side is 3x, so the other side is 3 times 17, or 51. Okay, again, we cut out 10 inches, 5 from each, so that's 41. And then the box is 5 inches tall. And if you check, 7 times 41 times 5 is in fact 1435. Okay. And again, just to be a little bit careful, it says what should the dimensions of the original piece be? So again, our sheet that you start with, right, will be 17 inches by, remember, 3 times it is 15 inches. 51 inches. Okay, so again, that was the question, the dimensions of the original sheet before you cut out the corners. Once you cut out the corners, remember, it goes down to 7 by 41, and then times the 5 to get the volume. Okay. And then for part D, we're asked what dimensions of the original piece of metal will assure a volume greater than 2,000 but less than 3,000. Okay, so again, notice here you're not being asked for a maximum, because I don't think there is one. Remember, we can make the sheet as big as we want, and it appears the volume would just keep increasing. Okay, so what if we want it to wind up between 2,000 and 3,000 though? That's part D. Okay, well let's take a look at our graph. Okay, so we have here our function x minus 10, 3x minus 10 times 5. Okay, for my window, again, I had a minimum 10 of, a minimum for x to be 10. I just went to 30. I'm just kind of guessing right now, otherwise it becomes a bigger sheet of paper. Okay, and then remember, your output is the volume, and I know I want it to be between 2 and 3,000, so I'm just putting a little extra on there and going from 0 to 5,000. And we see our graph. Okay. Now, keep in mind, it doesn't look like a parabola, but we don't see the whole thing. So I'm going to change this really quick. If you go back and change this to negative 10, even though it doesn't make sense, right, because your sheet can't be negative 10 inches long, then you get a better idea of where the parabola is in the picture. Okay. But again, we're only interested in this part of it because x has to be greater than 10. And again, it gives you an idea that the volume keeps going up. The bigger the sheet becomes, the bigger you make x to the right, the bigger the volume becomes. Okay, but let me go back to my original window and just make this 10. Okay, and then we want it to be between 2,000 and 3,000. So we just put in those two horizontal lines, remember, 2,000, 3,000. This will give us a nice graph of what we're looking for. So again, from here, from this x to this x is where we're looking for it. Okay, so we can find the x value here and the x value up here. We'll have what we need. So again, I'll show you the first one. Remember, you're just calculating. Oh, get rid of that. Keep hitting the wrong one, sorry. Calculating the intersection. So remember, here you're asked which curve. So the first curve, notice up here, is showing you y1. That's the one curve I want to be on. Hit enter. The second curve is in fact this one, the one that's equal to 2,000. So hit enter. And then again, your guess. So I'll move over just a little bit. And we get an intersection of 18 for x to be about 18.7. Okay, so let me write that down. So again, for part D, if x is about 18.7, again, that would give us a volume of 2,000. And then if you do the intersection for the other one, you're looking at about 21.2 inches. And that would give you a volume of 3,000. Okay, so again, for the sheet, the smallest you want it to be is 18.7. And then let me just quick remember it's 18.7 times 3. So it would have to be by 56.1, the original sheet. So remember, that's just 3 times. And the largest you want the sheet to be, so the volume would be 3,000, is 21.2. And then again, we multiply by 3, and you get 63.6. Okay, and again, this is the one that gives you volume equal to 2,000. And this is the one that would give you volume equal to 3,000.